Welcome to question 5 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 5 we have, for Jack to log on to his computer successfully, he must type the correct password. Unfortunately, he has forgotten the password. If Jack types the wrong password, he can make another attempt. The probability of success on any attempt is 2 in 5. And we're going to assume that the result of each attempt is independent of the result of any other attempt. A maximum of 3 attempts can be made. What is the probability that Jack does not log on to the computer successfully? So in other words, he gets 3 fails in a row. So if the probability of success is 2 on 5, then the probability of failing is 3 on 5. So we just have 3 on 5 times 3 on 5 times 3 on 5. And that is going to equal 3 times 3 times 3 is 27. On 5 times 5 times 5 is 125. So that is the answer to part A of this question. For part B, we're asked to calculate the probability that Jack logs onto the computer successfully. We're asked to express our answer in the form A divided by B, where A and B are positive integers. So the answer to part B is the complement of part A. That is, if he does log onto the computer successfully, that's the same as 1 minus him not logging onto the computer successfully in the 3 attempts. So we're going to have 1 subtract 27 on 125, which is going to equal 98 on 125. So that is the answer to part B of this question. So for 5A, we have that students clearly identified what was required, but some students did make an error with the arithmetic that was involved in evaluating, and that overall 76% of students got that mark. For question 5B, we have that 2/3 of the students got the mark, and that students generally recognised that the solution was the complement of their answer to part A. Others also successfully used a tree diagram to identify all possibilities for Jack logging into his computer successfully. For part C, we're asked to calculate the probability that Jack logs onto the computer successfully on the second or on the third attempt. And we're asked to express our answer in a specific form, C on D, where C and D are positive integers. So logging onto the computer successfully on the second attempt is the same as failing on the first but succeeding on the second. And then logging in on the third attempt is the same as failing on the first, failing on the second, and succeeding on the third. So now calculating the probability of that occurring, failing on the first attempt is 3 out of 5, multiplied by success on the next attempt, which is 2 on 5. And then we add to that the next case, which is failing, and then failing on the second attempt, but then succeeding on the third attempt. Now our job is simply to simplify this down into a single fraction. So 3 times 2 is 6, on 5 times 5 is 25. And then we add to that 3 times 3 is 9, times 2 is 18. On 5 times 5 times 5 is 125. And then getting a common denominator, this is the same as 30 on 125 plus 18 on 125, and that just equals 48 on 125. So that is the answer to part C of this question. From the examiner's report, we can see that 50% of students got this question fully correct, and the examiner goes on to say that many students who struggled with the previous parts of the question generally made good use of a tree diagram to find the 2 required cases. Some common errors included using conditional probability, or the use of the binomial theorem, or not realising that once Jack had logged in, there was no need to keep attempting a login. A small number of students realised that the probability of success on the second or third attempt was equal to the probability of success overall minus the probability of success on the first attempt, which mathematically was 98 on 125, subtract 2 on 5, which also gave 48 on 125, which was the answer required.